33. And keep going on forever. Eventually you get 33.3 repeating, which is 1/3. There it is. Yep. So it's gravitating towards that point.
So you do the first number you get
First number
plus the pattern minus 1 on the denominator.
Yes. Yeah. If it's 1/20th on the test, that's 1/19. It's always one less. Okay? So it's the first term plus that fraction of that first term. That's always how it is. Okay? And that'll get you all the rest. Right? And that works. Okay? So that's the best way to do those. You don't want to keep trying to add them. I guess you could kind of guess what it was, but that's kind of hard in some cases. It's easy here. In some cases, it's kind of hard to see. So use that pattern, you got it. Okay? Now, number 19, kind of like this actually, except it's going to be finite. A salmon slips off the top of the Christ the Redeemer statue.
That's what he's saying.
What was he doing up there in the first place? Walking around.
Eagle dropped it.
An eagle dropped it. There you go.
There you go.
Okay? And he's on top of the Christ the Redeemer statue. Perhaps the most recognizable icon in all of South America. Hence, why the picture was made at Christ the Redeemer statue. You can turn the camera back to. Anyway, it's one of our 7 continents pictures back there. So it's on top of that statue, 99 feet tall, and there it goes. Splat. Bounce. It's going to bounce. Apparently, it's going to rebound to 1/3 of its previous height. Okay, this is a rubber salmon. All right, so it's going to drop 99 feet. Then, on the first bounce, it's going to rebound how much? 33. But remember, what goes up must come down. If you go up 33, you come back down 33. There is impact, number 2. And then, if we divide that by 3, up 11 and down 11. There's the third impact. And then finally, let's see, we're going to the 4th. Yep. So what is 1/3 of 11? 11 thirds. Up 11 thirds, down 11 thirds. 4th impact. And that is not an infinite series. This is going to be a finite series. We just add to that point. So you get 99 plus 2 33s make a 66. 2 11s make a 22. 2 11 thirds make a 22 thirds. And if we add all this up, okay, 99 plus 66 is what? 1. Yeah, just borrow 1 to make it 100. Isn't that just 100 plus 65 really? Okay, so it's 165 plus 22, 187. And then think of this as a mixed number again. 3 goes into 22 how many times? 7 1/3. And 187 plus 7 is 194 and a third. There it is. And it's not going to bounce too much further than that because the other bounce is going to be so small. Not going to go very far. Put units, put feet. Don't forget that. All right. Exactly.
So it says how far does the salmon travel upon the 4th impact?
Right.
Do you mean like you're looking for that answer?
Yes, exactly. Yeah. Not the infinite bounces, which is that's the pattern. Just 4th bounce right there. Just add up all those.
I just think it kind of sounds like you're asking like on the 4th bounce, so it would be like 11 those, but you mean like the entire how far is it traveling?
Right. Like the 4th impact is right when it's hitting the ground right here.
Right.
Who's confused upon your word?
That's a fish.
Right. That's
It's a happy fish.
That's a terrible fish.
It's not
Very
a
happy.
It just kind of told you.
It's on the
It is an eel, yeah. When the eel hits the ground the 4th time, right at that very moment, that's when you cut it off right there. That's why I count them, because it's kind of tricky. If you actually write them out, 1, 2, 3, 4, then you'll know that 4th impact stops right there. And then that one to stop. So, that's it. Sure, it's a happy eel. All right, so let's go on to derivative patterns, everybody's favorite problems. All right, can you do sequences, but with derivatives? A lot of them have nice, clever patterns. Okay, third derivative of y equals 2x plus 5 cubed. And I gave you a big hint here, factorial / exponential
Can you give
form.
those to us on the test?
Yes, I will on this one. Okay, wink, wink, there's going to be a factorial and an exponential in your answer. Okay, so let's try it. Okay, first derivative is going to be, what do we do first?
Bring down 3.
3 to the front, base
Stays the same.
stays the same.
Power draw by one.
to the second.
Chain rule.
Oh yes, the most important part, right? Times
Those.
2. Don't forget to do that. Okay? All right. Now, we are accustomed to making 3 times 2 is 6 and combining them.
Don't combine.
Don't combine them. We're looking for a pattern. Don't put 3 times 2 is 6. It's correct, but we don't want that right now. Okay? You'll lose your pattern. Now, the 3 and the 2, since that really is a 6, it would actually just carry because it's a coefficient, right? So in the next derivative, the 3 is still there, but who joins the party? The 2 comes down. Normally you would make that 6. Just write 3 times 2. Like that. Okay? 2x plus 5 to the first. Now that 2 carries because all coefficients carry. If you're multiplying by a number, it carries, you'll notice. Now if you're adding a number, it just becomes 0, right? But if you're multiplying by a number, keep it there. But then the chain rule is another 2. All right? Got that? Okay, we're only doing 3 derivatives, so the third derivative will be 3 times 2 carries 1, comes down, 2x plus 5 to the 0. 2 2's carry, okay? And then the Predators games, the whistles. Okay, and then another 2 jumps out, okay? We go to hockey games here?
Yeah.
Just me?
Yeah.
All right, and then you get this. Now, what is anything to the 0 power? 1. Gee, that looks awfully familiar right there.
3 factorial.
That's 3 factorial. Okay, 3! Exclamation mark. Okay, and then 2 times 2 times 2 is 2 to the third, 2 cubed. That's your exponential, and you have got a winner right there. Factorial exponential.
Do you not want us to work it out?
No, keep it. Just keep it.
Oh, I thought we were doing that.
Now you want to see the factorial and exponential in your answer there. So there's your exponential.
What do you actually?
I prefer that you don't. It would be some points off because I want to see the pattern. I want to say, oh yeah, factorial. Okay. Then of course the next derivative after that is pointless because the next derivative after that is 0 because there's no x left, right?
And so then
That's just a number. Derivative of a number is just 0. So the 4th, the 5th, the 6th, the 7th, all the rest are just 0. Yeah. So it's pointless then. Of course, there's really not that you measure in real life other than the first and second derivative. There is, you can use a third derivative occasionally, maybe as an engineer, but for the most part, we would use the first and second derivative, which we will do very soon on a test.
Would the third be like right on
The real life applications.
the, like, right on, because it's a number and it would,
Yeah, so it does mean something, but then after that, and even if you have x's in your fourth derivative, you don't use the fourth derivative to measure anything, so. All right, so here's the 27th derivative. Oh my gosh, Mr. Wade. We have to do 27 derivatives.
Yay.
how many rows?
You'll be done. You can do the short. You can do the shortcuts. All right, let's do shortcuts and do that instead. So here we go. First derivative is going to be the derivative of negative sine of 6x is going to be
Cosine of negative
negative cosine of 6x.
times
Chain rule, most important part, times 6, right? Put that on there. Very important. Okay. Now, okay, so far so good. Second derivative. What's the derivative of negative cosine?
sine.
Positive, remember it changes, right? Positive sine of 6x, that 6 carries,
And another one?
but then another 6 comes out. Don't make it 36, it's tempting, just leave it 6 times 6. Or 6 squared would be fine too.
What's the rule, this cosine means cancel or whatever?
So the cosine derivative changes the sign in front, remember that. The sine derivative does not change the sign in front though, right? So the sine derivative would just be cosine, right? Okay. Cosine 6x, another 6 jumps out. I don't want you to write 6 times 6 times 6 is 216, we don't need that. Okay, just leave it 666. Whoa.
Now you got 6 cubes.
let's
Yes,
put
6 cubes,
6
yes,
cubes.
yes.
No, it's fine. That's what Starbucks total every morning.
So, 4 6 cubed,